I am Poop Witch X, and I am joined by the incredible, the wonderful, highly intelligent Helen from Fred Hutch. How are you, Helen? How are you? I almost said FRELEN.
FRELEN is a great name, honestly.
And Helen together.
Fred Helen. Honestly, that would be a sick name, and I would gladly accept it. It's a lot of paperwork to change your name, so I'll stick with just Helen. But FRELEN is great. Sounds like an elf from Lord of the Rings, so I'm here for it. I'm good. How are you?
It really does sound exactly like.
Doesn't it?
It does. FRELEN could definitely be from Lord of the Rings. Let's just go with that and say that's where it went instead of the brain pudding that's actually happening. So thank you so much for joining us. I just want to ask before we get started what your pronouns are.
Oh, yes, I use she, her pronouns. And you?
Yes, she, her as well. Okay. And we are going to get into this amazing PowerPoint presentation that Helen created. And I'm so, so excited to have her get into the nitty gritty of everything Fred Hutch. So take us away, Helen.
Yes, it is so funny to me to go from what I just watched for that half hour to like, so here's my PowerPoint, but I have a PowerPoint.
That's the beauty of the Poop Coven. I swear. It's like, the dichotomy between absolutely getting railed and then now we're going to learn about how you guys are kicking cancer's ass. So that's what the Poop Coven's all about.
Amazing.
Yes.
Amazing. I love it. I love
it too.
That's what life is about. Life is about humoring and tolerating, embracing the cognitive dissonance of like 1 second being incredibly intellectual and the next second being like, I think we need cereal for dinner.
Yeah.
And then the next second, something that's completely unrelated. Like, that is life.
I never know what's going to happen in here. I just hang on by my little fingertips and just pray that everything is intact by the end. And usually there's a little Stella is missing sometimes, but we'll get into a Stella. I'll tell you who Stella is another time. So we don't have to talk about things like that.
Amazing. Something to look forward to.
Okay. The inside joke.
Well, for now, we can go... Well, for now, we can go to the next slide if you want.
Okay.
Amazing.
Let's go.
So our next slide is just telling us what we're going to talk about today. So we're going to talk a little bit about who is Fred Hutch, not FRELEN, but Fred Hutch. We're going to talk about the relationship between viruses and cancer. And we're going to have a little bonus on bone marrow transplantation basics because it's a very interesting thing that most of us don't know that much about. Then we're going to have a little bonus. It's just one slide, but it's a little Poop Coven bonus just for y'all. And then time for Q&A. But also, like, this is obviously conversation. So, like, you and I, interrupt me at any time. People in the chat, like, interrupt us at any time. Like, that's the point. I'm not going to be reading the chat super closely.
I got you.
But I will be keeping an eye on it. Okay.
Yeah, I'm keeping an eye on them. Don't you worry. I'm keeping an eye on them. All right. So next slide.
Next slide.
Perfect.
This is a boring slide. This is just me.
Boring. No, we want to hear about you,
boring.
Please. No, you are the antithesis of boring. Don't get me started over here.
I don't know. I'm kind of a grandma. Most nights I end my day just reading on my couch with a cup of tea, like I'm actually 80.
I do. All I do is read, but the things I read are very inappropriate. So that's different, maybe. But like,
it's still reading. It's still reading.
It is definitely still reading. And also I have all the granny hobbies. I love knitting and crocheting and all that.
Good.
So I mean, we're all just like little old ladies enjoying ourselves.
Exactly.
Perfection.
So my story of how I got from the little old lady I was born as to the little old lady I am now, kind of skipping we'll skip the first 18 years. I grew up. I was an adult. Went to undergrad. For college, I studied cell molecular biology. You studied neuroscience, right?
I did, yes.
Okay, so pretty similar.
Yeah.
I worked in a neuroscience lab, and then after undergrad, I worked in a biotech lab for a few years, like doing research. Specifically, I was studying cardiomyocytes, so that heart muscle cells grow, move, and divide. And we were doing a lot of imaging-based techniques, so exploring how these cells sort of change shape over time, what they look like. And that was really cool work. But while I was doing all of that for my job, after work, I was doing a lot of volunteer work with different folks with different neurotypes. I was doing working at a crisis line, just like as a phone worker, because I just enjoyed it. I was tutoring. And I really just like loved connecting with my community and learning more about all the different ways that people can be people. And that was super cool. But after a while, like, burnout's a real thing. And I was like, I can't keep doing both of these things. So I need to find a way to combine them.
Right.
And so I learned about genetic counseling. Have you heard of genetic counseling?
I have, yeah. Mostly with like IVF and things like that.
Yeah, okay. Yeah, absolutely. So genetic counselors are trained healthcare providers who help people understand their own genetic information, their DNA, the instructions that tell our bodies how to work, and then help people use that new knowledge and that understanding to make diagnoses sometimes for certain genetic conditions. And overall, just to empower themselves to make decisions that feel right for themselves and their families. The reason you think about it with IVF or like prenatal medicine is that sometimes folks have a genetic condition that they don't want to pass down to a child for some whatever reason. It's incredibly personal.
Right.
And they might choose to do IVF so that they can test the embryos prior to implantation to make sure that the embryos they're implanting don't carry the same genetic change.
Right. It's so cool. And I think that bridges you into what you're really focusing on for Fred Hutch, right?
Exactly. And so I did that for grad school, but then my sister's still here in Seattle and I really like her. And so I was like, damn, I guess I'll move home. And my friends are here. And you know, the job at Fred Hutch was just such a cool, unique opportunity.
Absolutely.
So my current job, I'm a scientific content liaison, which basically means I get to talk to all of our faculty and learn about their work. And then I'm housed within philanthropy. So then I work with the rest of our philanthropy team to help share all of that knowledge, all of that research, all of that learning with the public and make sure that we fundraise for these guys so they can continue doing the incredible work they're doing. Because like, there is some cool stuff going on at Fred Hutch. Like I don't know about you, but I've always been the kind of person who's like passionate about my job, passionate about my patients, my work, but I've never really been like loyal to a company before. But like, I don't know, working with Jackie, who you've like worked
Jackie.
with, and like, she's the best. And like all of the faculty, like everyone here is so driven and like single-minded. It is like inspiring every freaking day.
Oh, I love that.
It's cool. But yes, that's why I'm here. Yeah.
And I think that like you bridging those two kind of, you know, between the philanthropy side and the science side is why you are absolutely the perfect guest for us to explain what is going on at Fred Hutch. So are we ready for the next slide?
Hell yeah. Yes. The next slide's even more boring. So we're ready for the one after that.
Anything is boring. Fred Hutch. Let's go. Let's do it. Next slide.
Next slide. So our next slide is one of our sort of founding philosophies at Fred Hutch, which is science meets care. So our mission at Fred Hutch is to cure cancer and infectious disease worldwide. And the way that we're going to do that is with a bench to bedside approach. Have you heard that term before, bench to bedside?
I have not. I'd love to hear more about it. No.
Okay, yeah. So bench to bedside basically refers to the lab bench. So a lab bench is basically just like a bougie way to describe the desk that scientists do their work at.
Right.
And so we're talking about how we want to take all of the research that we're doing at Fred Hutch and immediately bring it into patient care. So bench to bedside, the patient's bedside.
Love that.
And yeah, it's so cool. Like Fred Hutch is really passionate about clinical trials.
Right.
Because clinical trials are how we challenge the standard of care. We say, okay, this has been working, but we're seeing places that it could be better. And we want to make sure that we're not just saying it's good enough.
Right.
Because where we are with cancer care these days is we're trying to move beyond survivorship and not just help people survive their disease, but help people actually live lives that the kind of quality that people want after treatment, right? We want to avoid relapse. We want to avoid side effects. Like, yes, we need to treat cancer, but we need to understand it in and out so we can prevent it from ever occurring in the first place and make sure that if it happens, we detect it as soon as possible, we treat it efficiently, and we ensure that it never comes back. So that's the bench to bedside approach.
And I love that. And I think that as we've been going through the campaign and when I have a second in between them, you know, blasting me to explain that Fred Hutch is yanking cancer out by the root. It's not just treating on a systemic level where it's like we're trying to fix the after and even through like chemo radiation, you know, there's so many things that happen to your immune system after. Like it is a root rip out approach, which I think makes Fred Hutch really uniquely special. And I think that's why it's
100%.
It's resonated so deeply with so many people in the Poop Coven. Yeah.
Exactly. And because like the Poop Coven is so like curious.
Yes.
Like
so
y'all
curious.
are a passionate group and you're so curious. And I think those are the people who understand why what Fred Hutch is doing is so special and so important.
Absolutely.
Like Fred Hutch, we have 7 different research divisions at Fred Hutch. And one of those is our basic sciences division. And a lot of times people don't like quite get why we have a basic sciences division because basic science is just studying like fundamental biology. But it's because like you're saying, if you want to rip something out of the roots, you have to know where the roots are.
Right.
And so like we have scientists that are like, we're just going to understand how cells function because we understand that if we can understand how a healthy cell works, then we're going to understand what makes a cancer cell different. And that's going to help us target them. That's going to help us keep people healthy.
So it's, I know that for some of you guys, and by the way, this is an open communication. So if there's anything that Helen is saying or I'm saying that you really want to like ask specifically, please feel free to ask and I'll pull it and give it to Helen. But what I think is so important about what the mission is that, you know, we talked about that in our separate meetings of like, how do you explain also something as complex and complicated and also like niche in some ways as cancer to people, because everyone's cancer is also fundamentally different to their own bodies. And so you going back to the fundamentals and the basics of what makes a cancer cell, I think is such crucial science and so cool. And like, so awesome.
Yeah. Yeah. And that's why I think what you do is so important too, in that like what you just said, like everyone's cancer is different.
Right.
Everyone's cancer is different and everyone deserves the opportunity to understand their cancer.
Absolutely.
People don't have to talk about their disease if that's not what helps them.
Right.
But I think a lot of people find it less scary if they know what's happening. And so they deserve care providers who are going to explain what's happening and trust in their intelligence. Patients are intelligent, resilient people.
Yes.
We deserve to have a say in our own healthcare.
Yeah.
And like the clinicians that I've met at Fred Hutch are so like passionate about making sure that their patients are active participants in their care.
Yes.
Because they should be, and we should be, you know?
Yes, absolutely. And I think it makes something as daunting and often terrifying as like cancer, and that it can be all the unknown. It makes you feel like you have some control of an uncontrollable situation. So
exactly,
I think it's amazing what you guys are doing. Are we next slide in it?
Next slide, which actually answers, I noticed a question in the chat, how long has the association been around? And the next slide will help us address that.
Wow.
So Fred Hutch is currently celebrating our 50th anniversary.
Woo!
And we were founded in 1975 by Bill Hutchinson, who's the gentleman on the left. On the right. I know my directions.
I do the same.
And Bill Hutchinson was an oncologist practicing in Seattle. He was practicing at a hospital in downtown Seattle. And he was already studying cancer and doing a lot of research in cancer and treating patients for cancer, when unfortunately he was the one who diagnosed his brother, Fred Hutch, a baseball player and a coach, with cancer. And unfortunately, Bill's brother, Fred, passed away.
Oh.
And when Fred passed, Bill kind of had this moment where he was no longer content to just treat cancer. He wanted to ensure that no one else felt the pain that he felt losing his brother. And he wanted to fundamentally revolutionize the way we treat cancer. Oh. And that's why our mission is not to treat cancer. Our mission is to cure cancer and infectious disease worldwide.
Yes.
And that's all based on this vision that Bill had for the future. And I think that what's so moving, I was chatting with a donor the other day, and they were talking about their legacy, right? And they were like, we've been thinking about what we want to leave to our children. And they were thinking like financially, what they could leave to their children. And they started talking about how they've wanted to get more involved with philanthropy because they're thinking about the legacy they want to leave their kids. And like, we can leave our kids financial safety, and that is non-trivial.
Of course.
But we can also leave our children a future free of cancer and infectious disease. And that is also non-trivial. And I was like very moved by that. Because I was like,
amazing.
That's like, again, like I feel like I'm like drinking the Kool-Aid, but it's like actually like a tasty drink. Like
I also
crazy.
just feel like you have to be passionate about something that's so heart-wrenching so often.
Yeah.
And you're hearing stories from people of like Bill, who's like lost somebody so important to them. So I think that you feeling that like inspiration all the time and feeling so connected to the cause is really important. Because for me, like cancer is, I have health anxiety, so focused on cancer. Like ironic, there's lots of other illnesses that can, you know, we all know, but that's my like big boogeyman. And
so reasonable. That's a very real thing.
Right. And so what's so interesting is like whenever we do a cancer associated charity, it's like me also having to like fight the boogeyman. And like that's what made the Poop Coven. And when we have Helen and Jackie and we're talking about this, and we're talking about that it was all based off of the loss of somebody who was very near and dear, Fred Hutch. Like I think that it makes the conversation easier for people going through it, and then also gives the space for like us all to conquer our sort of boogeyman. So I think it's amazing. And I love that Bill Hutch created this in his brother's legacy, and now look at all the good that's been done. It's absolutely incredible.
Yeah. And actually, if you go to the next slide,
yes,
that's when we talk about things that have been done. This is the last 50 years. This is just a timeline of sort of like some of the stuff we've done. I won't get into too much detail because we're going to cover a lot of this.
Okay.
But one of the ways that Fred Hutch sort of like set the stage for our success as a leader in the fields of cancer and infectious disease was by pioneering the bone marrow transplant with an unrelated donor. So basically what that means was, we know that bone marrow transplants, now stem cell transplants, when you take a sample of the bone marrow or stem cells, which are these kinds of cells that have the ability to become many different kinds of cells, so like little baby cells with so much potential.
Yes.
We found out that if we take them from a healthy person and replace a sick person's bone marrow stem cells with a healthy person's, we can cure their disease. And that sounds kind of obvious, like, yeah, you take out the sick thing, you put in a healthy thing. But it's actually an incredibly complicated process, full of risks.
Yeah.
And the fact that Fred Hutch was able to make this happen actually earned us our first of 3 Nobel Prizes in 1991.
Wow.
And that was awarded to E. Donald Thomas. 3 Nobel Prizes. Do you like how I said our Nobel Prizes?
Yeah,
Nobel
I
Prizes.
think that, obviously you earned it, Helen. I mean, like, this is amazing.
I've literally been a Fred Hutch for like 5 months. Like, I have no claim to these Nobel Prizes.
No, but you do, because like you're look at you, like you're spreading all of this knowledge and information to us. Like, this is amazing. You're a part of the Fred Hutch legacy. And so in 1991 is when the first transplant was successful, or when like what
1990, 91, 90. Oh, it's on my slide. Yeah. 1990 was when the first Nobel Prize was awarded, but that successful bone marrow transplant occurred in the late 70s, 79.
Oh, wow. Okay, got it. Wow,
yeah.
incredible.
And then since then, we've just continued to expand. So back then, it was just like the bone marrow team.
Yeah.
And now, again, like I mentioned earlier, we have 7 research divisions. We have hundreds, thousands of staff and scientists and providers. We've partnered with the University of Washington to expand the amount of patients that we can serve.
Yeah.
We have a cancer consortium with Seattle Children's, so we make sure that we're giving tailored care to young folks as well as folks who are adults. Because that care is different. Those cancers are different. And the psychological needs are different, right? And so we've just been doing so much great work since then. And we're going to talk a little bit about some of it.
Oh, yes. Perfect. One of the questions, and maybe this will be the next one, is do you focus on all cancers, skin cancer? Is there any specific cancers that you guys focus on?
Yeah, no, that's a great question. Yeah, I saw that in the chat about melanoma. So I'm glad you mentioned that, because I meant to bring that up and then I forgot.
No, I got you.
Yes. So we have specialists that study melanoma, which is a kind of skin cancer. We also have specialists who study breast cancer, prostate cancer, pancreatic cancer, lymphoma, which is cancer of the lymph, which is a kind of it's kind of related to your blood. Yeah. It's that kind of system. Leukemia, blood cancers, hematologic malignancies, those are blood related disorders. Pretty much any kind of cancer, we're going to have someone touching it. Wow. You know, we might not have someone who's like a specialist, because our scientists are very honest and transparent about like, here's the things I specialize in. Here's what I can help with. Here's someone who would like be the absolute expert in that.
Right.
But so far, I have yet to find something that Fred Hutch doesn't touch when it comes to cancer care.
That's amazing.
We have amazing researchers and scientists. Yeah. Yeah. And we even have a, no, go for it.
No, you, Helen, you.
No.
What I was going to say, I think that's so important because there's so many different kinds of cancers. And like we said earlier, cancer is also very specific within this person's body. Yeah. It's good that you're touching in all these different places to try to find the root to all of them, because each cancer is different and functions differently in the body. So I think that's awesome.
Exactly. Yeah. Absolutely. One of the things that we like to say in genetic counseling is all cancer is genetic, but not all cancer is hereditary.
Oh, wow. Did you guys hear that?
Right.
That's really interesting. Can you elaborate for them? Because that's a really, really interesting anecdote for them.
Yeah. Essentially, all cancer is genetic, because we know that healthy cells and cancer cells are different from one another, and they're different on a DNA level.
Right.
The DNA in cancer cells has been mutated, has been changed so much that cancer cell no longer behaves like a healthy cell.
Right.
All of those genetic changes allow it to evade the immune system, to grow and divide more quickly than it should, to move throughout the body to places it shouldn't belong. All of those things make a cancer cell a cancer cell. So we know that all cancer is the result of genetic changes. Most of the time, these genetic changes happen over the course of your life, right? As your body makes natural errors. Sometimes when your cells divide, they just make a mistake.
Right.
Usually your body corrects those mistakes, but sometimes they pass through.
Right.
Sometimes there's exposure to things that can cause cancer or DNA damage, like carcinogens, UV light, for example, in the case of melanoma.
Right.
And then this is how most cancers form. It's called sporadic cancer. Much more rarely, a person is actually born with a change in one of their genes that puts them at an increased risk to develop cancer later in life. And so that's what we call hereditary cancer. Now, that's very rare, which is why we say all cancer is genetic, but not all cancer is hereditary.
Got it.
Because only a small subset of people are born at an increased risk for cancer because they have a hereditary or an inherited predisposition.
Can I give an example of like the hereditary? Would that be like the BRCA1 mutation for breast cancer?
Absolutely, yes.
Perfect.
Yes.
So like that's one that you'll hear very frequently is a hereditary, like passed through from family to family. Well, family member to family member. Okay, so that's a good example of one. And then another question we had is, do you buy research from universities? Do you have access to the information? Like, is it free resource? Do you share freely? Do you receive freely? Is that part of the Fred Hutch way?
Yeah, that's a super, super great question. Yeah. So Fred Hutch is a research institute with tons of partners, right? So we partner with UW and we collaborate openly. We partner with other universities and organizations and we collaborate openly. We've recently initiated our alliance with 3 of the other major cancer centers in the United States. Dana-Farber, MD Anderson, and I think Johns Hopkins.
Oh, wow.
I hope I've gotten those right. But
we
it's this thank you. It's this powerhouse of these 4 institutions who, like you said, are all like, we're like, we need to solve cancer. We need to solve it fast. Now is not the time to be like competitive and protect our data. Now it's time to share. And so we started something called Kaya, the Cancer Artificial Intelligence Alliance.
Oh.
And we're figuring out ways to share data with one another in a way that is safe and protects patient privacy, because HIPAA is real and it's important.
Yes, it is. Yeah.
But HIPAA, for folks who aren't familiar, is just like the compliance document that we all have to follow as healthcare providers to protect patient data.
Right.
And then we want to protect patient data, but we want to share data so that we have access to more patients, more cancers, and we can understand it faster because we have more power. We have more statistical power.
That's
because
amazing.
With more data, we're able to notice these trends and these patterns that might otherwise be too subtle. We can hopefully see them faster, sooner, and more efficiently. Yeah.
I think that's amazing. And I think that's really
Does that make
important.
sense?
Yeah, absolutely makes sense. I think it's really important that we that universities, hospitals, research centers lean into the sharing, because we're all trying to figure out the problem and how to rectify this problem, because I think the statistic is 1 in 3 people will develop cancer, right? Yeah. So it's like this affects a lot, a third. So it's important that we figure it out together, and it's a group effort. And I think that's awesome that Fred Hutch is a part of that, which is great. Next slide.
Yeah. Yes, please.
Okay.
And actually, when we get to the next slide, this is a chance where I have a question for you.
Okay.
So we're going to chat about cancer and the relationship between cancer and viruses. And that's because when we were chatting, you were like, virology sounds cool.
So cool.
I want to hear a little bit more about like your interest and like the Poop Coven's interest in viruses.
Well, the Poop Coven, I would love it if they share it. I'm very vocal and I advocate for, body autonomy, but I also believe in vaccines, and I believe in the need, the science behind vaccines. And as we are moving through a climate that is more and more pushing back on the real science and the real people who have spent, not just in our generation, but generations of people who have spent and dedicated their time and lives to killing viruses, not just like eradicating these viruses. And now you're seeing a pushback, because viruses, although they're tiny, they're brilliant and effective. So we need to be educated in a way that we can understand. And I think that when we were talking, Helen and Jackie and I, when there are cancers that we know that they're viral, like HPV and things like that. But I think
we'll talk about later.
Yes, please. There's a lot of sort of overlap. I don't know if that's the right word, but they're between cancer and viruses. And I think that that's such an interesting subset that Fred Hutch focuses on, and that you guys are also at the forefront of vaccines. I just think is so important right now. So I personally wanted to talk about that because I think it sets Fred Hutch apart from a lot of the other ones. So that's why I'm into it. I mean, the Puma is going to go along because I love it.
Okay.
You put it. Oh, I tried to I looked through the slides to make sure I had everything, but I was trying to surprise myself. So I love that you put I love that you put a question and then they get to answer. So it's interactive. Yes. That's great. Yes. Okay, let's do that.
I'm giving a presentation to elementary schoolers on Monday, and there is so much participation in it. I'm so one of the lessons they have to learn is our bodies are made of cells. And at one point I have PowerPoint slides where it's our bodies are made of, and they're supposed to touch their nose when they see the right answer. And the first options are our bodies are made of Legos, cats, pizza, cells.
I mean, I think that pizza would be a good option.
I agree. Cats would be chaotic.
Would also be a good option.
But talking about chaos.
Oh yeah, please don't say chaos. If what we say it 3 times, it's oh my god.
No.
The poop gun. Okay, so let's ask the poop gun. What percentage of cancers worldwide are triggered by infections? A, 0%, B, 5%, C, 20%, D, 50%, E, 100%. So poop coven, spam your answers. Let's see. We got some C's so far. We got PV Jumper C. Okay. We got Carly says C.
We got 100%?
100%. I'd guess C. C. Well, I see C's is a common.
Okay.
Let's see. So
let's see next slide.
We got some D's. We got some C's.
Oh, we got some 50s.
Wait, we're getting some D's now. We're getting some D's could go very wrong in the poop coven if I say D too many times.
40 is a good guess. Yeah.
Okay, so if you want to see the answer.
That's not an answer. Yeah.
Da-da-da. C.
Yes.
20%. So, good job, C's.
The reason I've said 20, excellent. Yeah, round of applause for C's.
Yeah, we give them a hand.
Everyone though, because none of these are crazy. All of these could be possible.
Yeah, I was very surprised when you initially told me this number. I was like, holy moly.
Me too.
Yeah.
We think, and I put 20% with an asterisk.
Yes.
20% is a number that I've seen quoted in scientific literature, but when chatting with virologists and cancer experts, it's kind of hard to pin down because it's is the infection causing the cancer, or is the infection increasing your risk and then you develop cancer on top of that? What's the exact relationship?
Chicken or the
20% is a conservative estimate.
Oh, wow.
We think it may be much higher.
Wow.
But it's definitely at least 20%, which is why the D's weren't crazy.
Yeah, D's aren't crazy either. 20% of cancers worldwide are caused either directly or indirectly by viruses and or other pathogens, which is crazy. And that's what I thought was so fascinating, because I don't know if people necessarily know that right off the bat. So
and if we go to the next slide.
Oh wait, Carly said increasing risk for the switch to turn on. What is increasing the risk about when you get an infection?
Right. No, that's a super great question. Yeah. So, and that's something that we talk about too. So when we think about cancer as being genetic, right, which we were talking about earlier,
right,
how cancer cells become cancer cells when a healthy cell acquires or builds up, enough mutations, enough changes in its DNA that it's suddenly behaving atypically. One of the things that we talk about is that maybe viruses just make it more likely that cell is going to acquire the mutations. So it doesn't actually cause those final mutations, but maybe it makes it easier for the cell to create those mutations or to acquire those mutations. There's something about it that makes it a more hospitable environment for cancer.
So can I and bear with me because I want to test myself right now.
Absolutely, yes.
Just to put it back all the way when I was learning about this many moons ago.
I am still learning about it.
Humans will be probably, let's not go down the dinosaur path. But anyways, so what my understanding is cancer, let's just generic cancer, because they all really do function differently. Your cells are constantly folding and multiplying, right? And that's natural. And your body has a natural way to regulate it, which I believe is apoptosis, right?
Apoptosis is pre cell death. Yeah.
Right. So if your cell goes through a genetic anomaly, which makes it's a mistake. The cell that was normal misfolds, does something wrong, becomes a mistake. It's supposed to go through the normal steps that your body is constantly doing, and it should be eliminated by apoptosis, right?
Yes.
But what cancer does is it evades apoptosis and then it continues on. And so what I think Helen is saying is with the what is going on with the viruses, why your viruses are attacking your immune system. That's what they're doing.
Yeah.
And it's your immune system that are going in and protecting you from these misfoldings, right? Kind of. I know it's more complicated than that, but
this is brilliant. Yes.
What I think, like, again, because it's one of those things that you and I talked about a lot, is like, how do you explain something so incredibly complicated and make it so that, because I see some confusion, like, what does genetic mean? And I think genetic, it gets confused and distorted with hereditary a lot.
Right.
Because
exactly.
So genetic doesn't mean that if your dad had cancer, it means it immediately passes down to you. That's not what Helen is saying. What she's saying is genetic is the guts, the components of the cell is your genetic composition, and those are going awry. Then those are evading apoptosis, and those go on to become a cancer and fucking effing mess up your body. So I think I just wanted to clarify, Papa Wolfie, because I saw that it's not generations of cancer going back. That's not how that works. That genetic is the genetic guts of the cell, right?
Exactly. Okay. Yeah. I didn't see that comment, but my guess is it was talking a little bit about, like, how many generations? I found it. How many generations does cancer go back? Yeah. So that would be like a hereditary cancer predisposition syndrome, like BRCA1, like you were talking about earlier. And that's a case where the way that those mutations work, we can take a quick tangent to it.
Yes.
Because I want to answer the question. Because
please.
Is in our cells, we've got all of our cells. Our body is made up of cells. Yes. You know, like a house of bricks, we're made up of bricks, and those bricks are cells.
Yes.
All up in it. And in each of those cells, in most of those cells, some of them don't. Most of those cells, don't get lost in the weeds. Most of those cells, there's a nucleus. And that nucleus is full of DNA. And the DNA is just the instructions telling that cell how to function. So your DNA is really important because it's the instructions.
Right.
Most of the time, we're born with our DNA and all of it works. It might be different because every person is different. Absolutely. But it all works the same. You know, our legs work, our muscles move, our eyes see. All of that's great. There's a special subset of genes. Genes are like little subunits of DNA, each with a special job. There's a special subunit of genes called tumor suppressor genes. BRCA1 or BRCA is one of those tumor suppressor genes.
Right.
And what they do is help repair our DNA when it gets damaged.
Right.
And that helps to prevent suppress tumors, because by protecting our DNA and by fixing it when it gets damaged, the cells don't have a chance to accumulate mutations and become cancerous.
Right.
So hereditary cancer is when a person is born with a change in one of those tumor suppressor genes, like BRCA1, that makes it harder for those cells to repair their DNA and makes it more likely they'll develop cancer.
Right.
And those, like you were saying in the chat, those are the kinds of genetic changes that can get passed down from generation to generation for many, many generations.
Right.
But that's a very rare, probably about 5 to 10% maybe of all cancers.
Right.
Most cancers, the changes happen in the cells after birth and don't get passed down to children or between generations. Does that make sense?
Yes, that makes absolute sense. And I think that was the where, because I think a lot of people use like genetic in lieu of hereditary sometimes. And I think that's where the confusion sometimes helps. And I think
100%.
Yeah, I think, and it is really confusing because
confusing.
It's super confusing. And people spend their whole lives going to school just to figure this out. But what we're talking about here and what Helen, I think, is going to be focusing on with the viral component is not hereditary.
Correct. We're focusing on non-hereditary cancers.
We're not talking about when something's passed down through families. We're going to talk about how maybe infectious, like a virus, messes with your stuff and then could potentially become a gateway. Yeah. Is that a good way to say it? Like a gateway?
Yeah.
To cancer. Okay. I feel like gateway is close. Okay, so I went to the next slide.
Good. The next slide is just going to elaborate more the relationship between cancer and viruses. Okay. Also, gateway is a great analogy. I feel like 90% of science is just trying to figure out a good analogy to explain what's happening.
Also, one question from Abby.
Yes,
if cancer is hereditary, it'd be the same type of cancer. Yes.
Yes, and so it could be the same type of cancer, but we know that a lot of times changes in these genes put you at an increased risk for multiple kinds of cancers, right? So like BRCA1, for example.
Yes.
People are at risk for breast cancer, prostate cancer, ovarian cancer, melanoma, and pancreatic in some cases as well. Yeah. And the reason why we would say sometimes the same cancer is maybe your mother passes down that gene to the change in the gene to you. So you acquire that pathogenic variant and disease-causing change from your mother. And your mother had breast cancer and you also get breast cancer. Right. That would be the same cancer. Mm-hmm. But what if you got it from your dad? Right. Your dad doesn't have breasts. Right. So your dad might have gotten prostate cancer and you might get breast cancer. Right. So same gene, same predisposition, different cancers. for a variety of reasons. Sometimes just because people have different organ systems.
Got it. Does that
great question.
Kind of good clarification for that? Is it just that my DNA has a formula to make this stuff, but it's dormant?
That's a really good question too. Yeah. It's more that we know that the cancer cell, that your healthy cells, your DNA has to function proper ways. So it's not so much that it's dormant. I mean, kind of. Like,
right.
Kind of.
Yeah.
It's that when the healthy cell becomes dysregulated enough, when enough things cause it to be different.
Right.
So, yeah, you could argue that like healthy cells all have the potential to become cancerous.
Yes.
So yeah, you know what? Originally I was like, no, but now I'm like, yeah.
No, yeah, because I think that like if you take a completely like external, like let's negate the hereditary. What if you're, let's say you use a tanning bed.
Sure.
That's an external factor that is you're exposing your healthy cells repeatedly to something that's a carcinogen. Correct. And when you hear the word carcinogen, that means could give you cancer.
Cancer causing.
Yeah, cancer causing. So basically those cells that were originally fine get repeatedly blasted and then they go like, hey, well, you're gonna, and then they do bad things. That's evidently what melanoma sounds like. Helen, did you not know? Hey, over here.
No, the amount of times that I personify cells, frankly, is illegal.
I mean, like, illegal. I think of Osmosis Jones every single time. I'm like, I just immediately. But that's what like differentiated. So like if we're talking hereditary versus like external factors, you're like Elle and Helen clarified, every cell technically has the capacity to turn bad, but if you eliminate certain things, you're less likely. Like if you don't smoke and you don't do tanning beds, and there's lots of unfortunately carcinogens out there.
Right.
But then like talking about now, there's a question about HPV and herpes. So I'm going to let you talk about the next slide.
Yes. So we'll keep going. Yes. In fact, if you want to click to the slide where all three boxes are up, I can talk about all three boxes.
Yes, got you.
But a quick note before we get back to virus land would just be that cancer is so complicated for every person with cancer. It's a combination of things they were born with, even if it's not like a hereditary predisposition syndrome, that maybe there's something in your genes. And it's a variety of, like you were saying, environmental factors, some of which we can control, and some of which we can't control, like sometimes like cancer happens. Because I am representing Fred Hutch, I will not swear, but like, sometimes things happen and sometimes that thing is cancer and like it sucks and it's no one's fault. Right. It's like we have like autonomy and like we can do things to protect ourselves, but also like sometimes like it happens sometimes, Yeah. So cancer and viruses, because viruses also happen sometimes. Yeah. We know that viruses can cause cancer, right? We talked about this. HPV is responsible for 95% of cervical cancers, as well as 6 other types of cancer, including head and neck cancers, which people often don't think about. Kaposi sarcoma-associated herpes virus, or KSHV, causes Kaposi sarcoma, and that's 20% of all cancer diagnoses worldwide, which is crazy. HIV doesn't directly cause cancer, but HIV can lead to AIDS, which can put folks in increased risk for this triad of cancers that are characteristic of AIDS, which are Kaposi sarcoma, cervical cancer, and non-Hodgkin's lymphoma. And we also know that EBV, which in the United States tends to cause mono, can also cause Burkitt lymphoma, nose and throat cancers, and multiple sclerosis, among other conditions. Wow. Yeah.
Huh. I've heard of Epstein-Barr before. I haven't heard of it in a long time. Is that, because I remember, this is how things like resonate in your brain from when you're young. I heard it a lot when I was growing up. Like, it was in Clueless. I remember them saying it, and in Buffy, they reference Epstein-Barr in both.
Maybe because it can cause mono, which is like, I don't
know, but it's so funny because it's not something I've heard like colloquial you use like nowadays, but I remember being referenced in Buffy and Clueless as like the virus of the time. So it's interesting that like it's still around, but it's so funny how you like, I haven't has anybody here, I'm sorry, this was just a segue, sorry, that I just haven't heard it
an important segue
referenced in a long time, which doesn't necessarily mean it's less around. It's just that I don't know, that was the only time I ever heard of it.
No, I never hear about Epstein-Barr virus, ever. I mean, it's outside of work.
Right, outside of work.
Yeah, so, in my social life, it's never coming up. No one's at Thanksgiving like, you heard the news about Epstein-Barr? Like, no.
No. And honestly, so Epstein-Barr, as you're saying, is like synonymous with mono.
It can cause mononucleosis, which is a what is mono? It's like kind of like flu-like vibes, like achy and tired all the time.
Right.
Yeah.
Oh, wow.
And it can cause that, but it can also cause these other cancers.
Wow.
Yeah. The infections can actually inhibit treatments. So make your treatment for your cancer, your chemotherapy, less effective. And an example of that is there's this kind of chemotherapy called 5-FU. And they found that depending on what bacteria are living in a person's gut, their gut microbiome, that chemotherapy can actually be more or less effective because the bacteria can interact with it in a way that makes it less effective, which is crazy.
That's so, I think, and also like we as people, a lot of us in here have tummy issues and we've all learned that your gut bacteria is so important, and we associate bacteria in a negative way, but there's also bacteria in your gut lining your intestines that are like actually super important. And
they're so important.
So your gut microbiome is so important. Like not just like the bad stuff that we're all like, ugh, but the good stuff is really important.
Jackie and I were talking to one of our dietitians one time for a different fundraising event. And she said something that Jackie and I were both like, she was like, you have to feed your body well because you really have to feed your microbiome.
Yeah.
And I was like, oh my God, you're so right. My bacteria, they need me. I need to take care of them.
And they get thrown off like that. I swear. So you gotta be like careful
about. If you think my diet isn't like 40% fiber, my diet is so high. All the seeds and nuts, every legume.
I eat a lot of fiber too, but I need to even get more. Fiber is life. Fiber. So a question from Carly, do you give microbiome counseling before chemo? Excellent question.
That's a really, really good question. It's a really good question. Because I don't actively see patients, I honestly don't know if we give microbiome counseling before chemo. My guess is that it's not standard of care. It's probably not routine.
Right.
But it's something that I would not be surprised if a patient is receiving a chemotherapy that's known to interact with microbiome, like 5-FU. And they're seeing an adverse response or not as much of a response as they would expect, that they would then check the microbiome.
Wow.
But I'm going to take a note in my notes app to ask about that.
Can I also just say that I remember, and now don't quote me because I read a lot of science like articles and then like I file things away, but I don't remember every detail, but I do vaguely remember somebody's gut biome was like blasted out from chemo, and they actually got a donation of someone's healthy, I think it was poop or something, and put it in the person's stomach to like re-up their microbiome. And like, is that true? I swear I read this.
Girly pop, we will talk about that. And yes, it's true.
Oh my God.
Yes, it's true.
I don't forget anything that has to do with poop. I know everything about poop. I was like, I remember reading that and I was so fascinated. I was like, oh my God. Although I'm not in the sciences anymore, I still am like,
you are in the sciences. You are in the sciences. You're in the sciences for life. You're in the sciences. Everyone who engages with science is in the sciences.
Okay. I love this. I just want to say my microbiome is more chaotic than Nair during a golden kappa. That was such a good little joke. That's so good.
Oh my gosh. Also, yes, fecal transplant. Yes, it's a fecal microbiota transplant is what it's called. Thank you, Fred Hutch. Yes. Yeah.
Who has the best microbiome? Oh my God. And probably, honestly, in the poop coven, we have so many poop problem people in here. I don't know if we would be the place to scout that out, but it is a really fascinating thing. And I remember reading about it. And I think that's so cool. So
it is.
Viruses can slow recovery is also.
That's the last thing. Yeah. So they can cause cancer, they can inhibit treatment, and they can also slow recovery. So bacterial infections can cause aspiration pneumonia.
Right.
And that happened a lot in the early days of bone marrow transplant. So aspiration pneumonia would occur when patients are recovering from their transplant, but they're so nauseous that they actually throw up. And when they throw up, some of that vomit can sometimes get into the lungs. Or can cause infections, pneumonia.
Yeah. Also
and that can be
happens in
lethal.
Elderly too, unfortunately.
Yeah.
That was a big one when I worked at the hospice facility. That was what we were. Yeah. It's really it's a very unfortunate thing. But and all of these, what's interesting is, and by the way, just for people, I saw earlier about HPV. If you get that is being tested through Paps, I always want to say schmear because that's how we say it in the poop coven, but that's not appropriate. Pap smears. If you get your regular pap smears, poop coven, not schmears, you that's what they're checking for, right? So I just want to go back.
Yes.
I saw that earlier. Okay. Yep. And then also, do you want? I'm sure it's on the next slide, but I was going to talk about your vaccine for HPV.
Yes, we're going to talk about that. Okay. We got a couple slides, and then we're going to talk all about the HPV vaccine. But yes, exactly like you said, pap smears Now I want to say schmear.
I say every time I say it, I say schmears. Every single time.
It's just a more fun word.
It's way
Pap
more fun.
smears and colonoscopies are really great because they're two ways to screen for cancer, cervical cancer and colon cancer respectively, that also can serve as a pre-treatment. Because if we see it while we're in there, we can potentially just remove any abnormal cells while we're in there.
Right.
Super helpful. Yeah.
Which, as the Poop Coven knows, I got my first ever colonoscopy.
Okay.
And my doctor said,
how was
pristine. He said, pristine. And they were checking for me for Crohn's, colitis, IBS. And he was like, no, nothing. You're just lactose intolerant. Sorry. Now you get to eat no cheese. But he said pristine. I woke up, I was like drugged up. And he was like, I have to be honest, your colon was pristine. I even went into your small intestines, pristine. I was like, I'm putting that on in my resume or something. I'm like, okay.
It's wild how like praise from your doctors for things that like are totally not. You're just like, thanks.
Yeah.
My dentist gasses me up every time I go. He's like, your teeth are so healthy.
Your teeth are so beautiful.
Thank you.
They're so beautiful. They're so straight. They're so white. They're so beautiful. Oh my God.
They're aggressively average. They're aggressively average. But my dentist always gasses me up.
Oh my God. But no, seriously, I can't recommend. And the Poop Coven knows I'm an advocate for going to the doctor, getting your regular screenings, blood tests, getting a pap smear. If you need to get a colonoscopy, like doing those things, they can find things and do all the things. So, bone us. You're so clever. I love you. That's so funny.
Yes.
Bone us.
Before we talk more about viruses, we're going to talk about viruses in the context of bone marrow transplants.
Okay.
And I know that like when we talk about bone marrow transplants, I don't know about you guys, but I hate when someone's like, oh, this thing that we all know about, and I don't know anything about it. I'm like, I can't focus until we know about it.
Absolutely.
So we're going to quickly talk about what these are before we talk about what comes after.
That's awesome. Ooh.
Amazing.
I saw this lad. I did.
Yes.
I cheated. I looked at it already, so I'll stay quiet.
Good, you should.
It was too cool.
So we're going to talk a little bit about the big picture bone marrow transplant ins and outs. Now, bone marrow transplantation, since it was first pioneered in the 70s, again, with that successful donation and transplant at Fred Hutch in 1979, since then, we've come a long way. The process has changed a lot, but the basic steps have kind of remained the same. So first, what happens is you got preparation. So essentially that's diagnosing a person with the kind of condition that can be treated with a bone marrow transplant, also sometimes now called a hematopoietic stem cell transplant. What does that mean? Hematopoietic just means referring to the blood cells of the blood cell lineage. And a stem cell transplant is basically saying that we're taking those baby blood cells, those super, super powerful cells that we call stem cells, that are capable of becoming white blood cells, red blood cells, platelets, every blood derivative. They're capable of becoming those. And what we do is we can take those from a healthy person and then put them in a sick person, and they'll find their way into the bone marrow and they'll repopulate the bone marrow with bone marrow and also with all those healthy blood cells. So it used to be that we would just use bone marrow as that sample. But now we can actually get those same cells from peripheral blood, which is just the blood that's flowing through your body. We don't actually have to go into someone's bone most of the time, which is amazing
because bone.
Amazing.
They use, oh my God. So bad. So, I mean, not bad. I don't mean it in a bad way, but like man.
Donors used to sometimes die from the surgery.
Yeah, it was so bad. It was really, yeah. So it's so much better. And these stem cells are like powerhouses. They can go in and it's amazing. It's so cool.
Yeah.
It's so cool. It really is so fascinating. It's amazing.
Yeah. So step one is just identifying that a person has the kind of disease, usually leukemia or some sort of blood disorder, that can be cured with a bone marrow transplant. And then it's finding the donor, right? So step one, identify the disease, find that donor.
Right.
Sometimes you can do an autologous transplant. That's actually when you're able to take stem cells from the person themselves, a healthy kind of cell. But most often you see an allogenic transplant, which is when you actually have the donation coming from another person.
Right.
So these days, we won't get into it for the sake of time, but these days, typically an allogenic transplant comes from a person that we've tested. So we've assessed their blood and looked to make sure that some really important immune factors are the same in the donor and in the patient. So the patient's body doesn't attack the donor cells too much. And so the donor cells don't attack the patient cells too much.
It's a very fine balance. Yeah.
Yeah.
It's really, really
so, which is crazy. So that's the first step. Move my scarf. Ugh. And the second step is stem cell collection. So the slide's just going to take us through all the steps because I thought that the slide was like kind of overwhelming. So I added the little boxes to make it a little less overwhelming.
I love it.
Okay, cool. So next is the stem cell collection. So once we've got our donor, we got to get them stem cells.
Yes.
As I mentioned, most of the time we can get them from circulating or peripheral blood. So blood that's just like flowing through your body. So it's just like a normal blood donation if you've ever done that.
Right.
Sometimes you actually have to still go into the bone and get the bone marrow. It's still a lot better today than it was back in the 70s.
Yeah.
But that's more invasive. Mm-hmm. And then sometimes we use umbilical cord blood. So people who've had a baby will sometimes donate the blood from the umbilical cord because it's full of stem cells.
Yeah. Can I just also say, it's so interesting that when somebody is pregnant and they have the like literal book that can create an arm, a leg, like a brain, eyelids, eyeballs. But then once we're popped out, it's like you're done. And that's why stem cell research is so important, because these are builder cells that have potential to do anything and become anything. And it's so fascinating and interesting and incredible. And so, so cool.
Yeah. So cool. So cool. So then the next
one more question. Do you
please,
partner with
always.
hospitals on when parents give birth so you could collect the umbilical cord? Do they have umbilical cord donations? Like, how would somebody go about giving an umbilical cord? That's a great question too.
Yeah, that's a really, really great question. Thank you for asking that. Yeah, I think that's Carly Kim's amazing question. Yes. Carly Kins. Oh, that's a cute name. Carly Kins. So cute. Oh, that's super cute. I love. Yes. We love questions. Yes. I know that you can save if you're pregnant. Sometimes they'll ask you if you want to like save cord blood.
I've seen that before. Yeah.
But I don't think it's free. Yeah. And I don't think, I'm sure there's a way. I'm sure there's a way to donate, but I don't know logistically. So I'm going to ask about that.
That's a really cool question, because I think that you can definitely keep it. Like, you can definitely keep it for yourself and store.
100%.
And then I know you can also do that with the placenta, but the placenta is not the same deal as stem cells. But yeah. And then also Elle asked, do you work with monoclonal antibodies? I've been offered them for migraines or Botox. I get to choose between them, and I think they choose Botox because I don't know a thing about monoclonal. I don't know about monoclonal stuff either. I don't know. Super reasonable.
Yeah. So monoclonal antibodies just refer to antibodies. So antibodies, as you probably know better than I do, actually. Antibodies are immune cells in our body. So they're the cells that fight any infections or viruses, and they can also help to target these very specifically. So some of them are just like general fighters, but our antibodies, those are immune cells that very specifically target and fight one thing.
Right.
Monoclonal antibodies just means that it's one clone, monoclonal antibodies. So the same antibody just duplicated a bazillion times. Okay. So they're all genetically identical, which we will call clonal. They're all genetically identical.
Got it.
So monoclonal antibodies just mean antibodies made in a lab. I don't know about the use for migraines, so I have no opinions on that.
Yeah.
But definitely don't be afraid to hopefully your doctor is good.
Yeah.
And if they're communicative, don't be afraid to ask them. Be like, I'm not opposed to this, but I simply don't know enough about it. Yeah. And so I don't feel like I can make a fully informed decision because I don't have the information. So can you help me understand more about these?
It's a really good suggestion.
Yeah, and I love to ask doctors. I don't know about you, but like with your colonoscopy guy, who's obviously your best friend. I ask and I sometimes ask why would I do this? Why would I not do this? What would you do? What kinds of people tend to benefit most from this? What kinds of people tend to have the most side effects? Yes. How long do the side effects last? I am just unapologetic about asking questions, and
Me
don't
too.
be afraid to get a second opinion.
Yes. See, this is what I mean, Poop Coven. Me and Helen they always say that I should have been a medical advocate, because all I do is say, you have to advocate. Make a list of questions on your notes. Bring your phone in. Do not feel like you are wasting their time. That is what they are there for. Ask questions. And if you have a doctor who's evasive, no, I need this answer. And you don't leave until you get it. It's your body. You need it.
If you need to bring a support person, because it can be scary and hospitals intimidating, bring a support person. Yes. I bring a support person sometimes. Yeah. And I've been in the position, I don't know about you or anyone else out there, I've been in the position when I'm so scared of my health and so overwhelmed that I cry immediately setting foot in the doctor's office. And that's hard, because then you're trying to ask questions and be intellectual and be taken seriously as an adult, but you're sitting there crying.
Right.
You have to have grace with yourself, and you have to push through.
Yes.
They are supposed to talk to you, even if you are crying. Yes. You are still a rational person who deserves to be treated with respect and fairness.
Yes.
So don't be embarrassed if you're stressed, and it's okay. But you have to still take care of yourself. Yes. But also it's okay to be scared.
Absolutely. I love you so much. Yes, absolutely.
It's rough out there. It's rough.
It's
When
rough
you talk
out
about your cancer anxiety, it's real. Cancer anxiety is real.
Yeah, it is.
Because you don't know.
Yeah, I mean, I'll make sure I know as much as I can, though. So.
Screenings.
Yeah,
like you were
exactly.
saying. Yes.
Next, you want the next slide or?
Next one, pre-transplant conditioning. Yes.
Okay.
So we talked about preparation. We talked about getting the stem cells. Now we're going to talk about pre-transplant conditioning. So that's when you actually prepare the patient's body to accept the donation. And that involves wiping out their bone marrow, the stuff that's sick and diseased and causing the cancer, and also suppressing their immune system. All of those cells that would normally fight infections, we're going to turn them way down like a dimmer switch. Because if they're turned up on full volume, the minute you put that donor's cells in there, those donated blood cells, those donated stem cells, your body's gonna be like, that's not mine.
Get out.
Unacceptable. It's gonna attack it like it's a virus. Yeah. But you want those cells to do, next slide, what's called engraftment. So you want to get the person's body ready to accept the transplant. You want to do the infusion, put the stem cells in there, and you want them to engraft, which is when those stem cells find their way to the bone marrow, make a little home in there, and then expand, developing into all of the red blood cells, white blood cells, and platelets that you need that body to make. Mm-hmm. What's also cool is that the white blood cells that come from that donor, that come from those stem cells, those donor-derived immune cells are actually able to hunt out and kill any lingering cancer cells that got left behind.
So it's almost poetry, but it's like scary and terrifying. But it's if you I mean that's why like scientists can be reading a horrifying thing, and sometimes they almost look like they have like revere, because the immune system and your body and the things that are all going on are beautiful and they're terrifying, but like it's an incredible system that's taking place. It really is amazing. Have
you ever read The Emperor of All Maladies or anything else by Siddhartha Mukherjee?
No. Would I love it? Send me the
in
links.
Love.
Oh, send me the links. I love it. I would love it. I would love it.
So good. So good. The Emperor of All Maladies is a book all about cancer, but it's like told in such like a beautiful human storytelling way. Yeah. Siddhartha Mukherjee is an amazing science writer. He also wrote The Gene, which is a book all about genetics, and it's
I've heard that one. I actually think I have seen that one, but I don't. Not since I was young, so I mean, like I don't know. But it's been a hot minute since I've read anything like for real. From I read articles, but like books and stuff.
Articles are great.
Yeah, I like to keep up to date and see what the heck is going on out there. But
honestly, so much is going on.
So much is going on. So recovery.
Yes. So then there's recovery. And one thing that's cool at Fred Hutch is we have our long-term follow-up unit, or our LFTU program. And essentially, this is a team that's dedicated to following up with patients days, weeks, months, years, like years and years and years for life after your treatment to make sure that you stay healthy. And this is also great because it also gives patients a chance to contribute to research. I saw someone in the chat who was like, I would donate my cord blood. I just need to know how.
Yeah.
People want to help with research. People want to contribute to knowledge. And so some people will participate in the long-term follow-up program because, one, they'll get close monitoring for the rest of their life or for many, many years from these clinicians, these scientists they've come to trust and really love. Because these people trust and love them. They care about them so sincerely. These doctors care about their patients. So they get to maintain that relationship and receive this high quality care and support. But also they get to contribute data, because the scientists get to say, okay, now that we've done your transplant and you're safe to go home, what happens in a year, in 2 years, in 3 years, in 4 years? And they get to collect that data and help us continually improve the way that we treat patients. Yeah.
That's amazing. And I think that is something that's so important. If you're battling cancer and you overcome it, you need, because you can be fine and then obviously things can happen. So having that long-term care is so important and so helpful. So that's awesome that you guys do that for your patients. That's amazing.
Yeah. And talking about treating patients, we can go to the next slide.
Woo!
So the next slide is on infection control, right? So we're coming back to cancer and viruses. So how did Fred Hutch become one of the leaders in vaccines and infectious disease? So in the early 1970s, when we were doing those transplants, those very first transplants, life expectancy for patients was really low. What you see here is a gentleman in a lamellar airflow chamber. Essentially, they're kind of like these like sterile chambers. And even the food that the patients had to eat during recovery was irradiated. So it was treated to make it sterile. Because even if they survived their surgery, which many patients unfortunately passed away during surgery, the post-operation risks like nausea, infection, pain, rejection, which is when your body attacks the donated cells and they die, or graft versus host disease, which is when the donated cells attack your healthy cells in addition to the cancer cells. These things also could cause patients to pass away. And the main concern that they were really worried about was infection, because remember how we talked about how we turned the immune system off like a dimmer switch?
Right.
Because these patients are immunocompromised, they're very susceptible to infectious disease.
So,
and if we go to the next slide,
actually has a question. Doesn't suppressing someone's immune system also interfere with their TNF blockers, raising their risk of cancer?
I'm not familiar with TNF blockers, if I'm being completely honest. No. I love being completely honest.
No, I want you always to. And I think that's amazing. And I think, Andy, so when you're lowering someone's immune system, I think the question is it lowering your immune system makes it almost feel like you're more susceptible to getting cancer because your immune system is now able to prevent it. But what they're doing at the same time that they're lowering your immune system is they're flooding it with the things your body actually needs to start mending itself.
Correct.
So you're hoping that the good things coming in are going to decimate the bad things before the bad things can keep repopulating. So I'm not familiar exactly what a TNF blocker is either, but that's my basic understanding of, well, if you just left someone who's immune compromised and you didn't flush them with the good stuff, then their body will not do well and it could continue to have issues. But you're hopefully given lots of good stuff. Hi, Introvert Latina, welcome on in. We got a little raid from Introvert Latina who's also raising money for Fred Hutch. So welcome in, everybody. Yay. So that's the best I can answer because I don't know either. So I'm not.
Yeah.
That makes sense. Okay, so next slide.
Amazing, please. Yes. So the next slide, we're talking about CMV. And that's because, again, in the early days of bone marrow transplant, aspiration pneumonia was common, we talked about earlier.
Right.
But CMV reactivations were particularly dangerous. And I wanted to highlight that word reactivations. So cytomegalovirus is a virus. It's an infection. Most people are infected with CMV at some point in their lives. And most of the time, we don't have any signs or symptoms. It infects our bodies and it hides away in our bodies and it doesn't cause us any harm. But what they found was that usually it doesn't cause us any harm, right?
Right.
But when people were recovering from bone marrow transplants, because they were immunocompromised, even though we're flooding their body with the good stuff, even though we're putting new immune cells into them, during the early days, the people who donated their bone marrow would also have to stay around because every day they would take a donation of white blood cells from this person and infuse them into the patient to help them recover. So even though we're trying to give them an immune system again, their immune system is still so low that sometimes the virus, which was already present in their body, can wake up and suddenly it wreaks havoc, even though normally it doesn't hurt us.
Right.
And so 40% of patients following the transplant would die from these infections.
And this is from the 70s, just to clarify.
Yeah. So these days, no.
They got this locked
70s.
down now. Just wanted to clarify. Yeah, this is the OG days where literally people who were doing donations back then were like literal heroes because they were also compromising their bodies and putting themselves at risk for infections as well because doing repeated donations. And so that's unbelievable. And now these are things that we've learned from.
Yeah, I should clarify that these days, bone marrow transplants and stem cell transplants have an over, I think it's at least 90, I want to say it's 95% like cure rate.
Amazing.
Like people will be cured of their disease. Like it's, in the last 50 years, we have like done a 180 on this disease. Yeah. Like, which is amazing. Yeah. And it's in part due to, next slide, a gentleman called Dr. Joel Myers.
Yay, Joel.
So there were yay, Joel. There were all these infections going on. And the doctors were like, well, one, we hate that our patients are dying. And two, it's also really challenging for research because we don't know if the transplants are working because patients are dying before we can see if the transplants are even helping. And so they're frustrated as doctors who want desperately more than anything for their patients to live. And they're frustrated as researchers because they're not even learning if what they're doing is helping.
Right.
And so they're like, we need to get these infections under control. So they hired a gentleman called Dr. Joel Myers from the CDC. And he originally was a one-person team that would grow into the Vaccines and Infectious Diseases Division here at Fred Hutch, which is one of the largest groups of infectious disease researchers at any cancer center. And he set a series of protocols in place, if you go to the next slide, for how to fight CMV. Oh my God, wait, someone signed up for NMDP. Sorry, I was checking the chat really quick. No, NMDP stands for National Marrow Donor Program. And it's where you can sign up online to register to be part of this big list of people who are like, if you need a bone marrow transplant, I can provide my stem cells.
Amazing.
And It's so cool. It's so easy. I'm on it. It's really, really easy to do. All you do is you like go, you sign up, you say like, yes, I would love to donate blood, to donate stem cells if you need me. And you fill out a quick questionnaire for like some basic health questions, your age, where you live. They'll send you a kit. You swab your little cheeky cheeks. You take those cheek swabs, you mail them back. They analyze the DNA from that cheek swab, and they record all those important factors they do when matching a donor and a patient. So they check all of the kind of factors they'd want to check for compatibility. They put it in their database, and then if you're ever a match for someone, they'll ring you up and say, hey, we've got someone who like needs you. Can you be a donor? Amazing. And 90% of the time, they can just do a simple, it's like blood. It's just like a blood draw.
Yeah.
So it's not the same risk.
It's not like it used to be. Yeah.
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 Jackie's also signed up. She's in the chat. She's also signed up. She's the coolest. Yeah. Also NMDP, last quick tangent. NMDP actually started at Fred Hutch.
Oh my gosh.
Yeah.
No way.
I know.
Jacko said you can sign up and there's a good chance you'll never be matched, but you could save someone's life. So that's amazing. I'm on the list too. I have to check. I was in college, but I don't think since I was in college. So that's something I got to look into. I don't know if it like expires or not, but it was when I was young.
I don't think it expires. I think after like 45.
Oh, okay.
Maybe they don't.
So I still
got
12 more years if I did the math right there. Yeah. Okay, so we're all right. Okay. I can't do math, so that's the closest I can get.
Okay. Well, you know who could do math? Dr. Myers. I actually don't know. You're just trying to. Maybe he could. He probably could.
He definitely could.
But essentially, Dr. Myers was like, all right, here are the things we're going to do to get these infections under control. 1, we're going to prove that CMV is the virus that's causing these people to die. And he was like, done, did it, proved it, CMV, on my hit list. 2, he was like, okay, so we know that these people are getting sick from CMV when the virus wakes back up in their immunocompromised bodies. We know that that's because the virus actually hides out in your cells in your body. What if the virus is hiding out in the cells of the donor, and then we're actually putting those viruses into the patient with the healthy cells from the donor? And so they started to screen all of the patient samples for CMV. And so that also cut down on infections because then patients weren't being exposed to it in the same way. They also developed an antiviral medication to treat these infections. So at the time, there was no medication that could kill cytomegalovirus or CMV. So he actually developed drugs that could actually fight and kill CMV. And they started to deliver those antivirals prophylactically. Prophylactically just means before a person's sick. So they were like, instead of waiting for a person to get sick and then treating them, we're just going to treat them with this medicine, which doesn't hurt them if they're not sick, but will definitely help them if they were to get infected. And so we're just going to start giving them that now just to be safe. And that was game changing, being able to treat CMV in these patients.
That is so cool. Sorry, I was processing what you just said. I just think
I talk very fast.
No, I talk really fast too. Don't worry. I was just thinking about it because I just think that the science of giving them it beforehand to just sort of be like, hey, we're gonna cover all our bases here, is that little pivot. I mean, it changed the game. Like just doing that beforehand, it's just so fascinating and so cool, and it made, I'm assuming on the next slide I'll say it made all the difference, but I guess we'll
if you go to the next slide, actually, yes. It made all the difference. 1, because it helped these patients, and 2, it inspired science to be like, viruses are important in cancer care. And so cancer centers across the world, including at Fred Hutch, were like, we need virologists. We need virus experts, because there was a relationship between cancer and viruses.
Right.
And so Dr. Meyer's team continued to grow, inspired the desire to continually improve infection management and also to understand how viruses and pathogens cause cancer. So we can go to the next slide. And this is just the face that I made when I realized it. I did not realize this. Literally, I started this job and I was like, oh my God, what?
Oh my God, that's so funny.
I make that face all the time. And then if we go to the next slide, we're going to do a little tangent on HPV, human papillomavirus. And that's because I'm glad we've talked about it in the chat, because it's very cool. And also because many people at Fred Hutch, especially one of our doctors who we'll mention, Dr. Denise Galloway, led the research that made the human papillomavirus vaccine successful, like made it possible.
Amazing.
Which is crazy.
Yeah.
So if we go to the next slide, a little bit about HPV. Oh, we can skip this because I talked about it earlier.
Okay.
But the next slide is on cancer-causing infections, aka HPV. Thank you. So yeah. Oh, sorry.
That one more.
Here's a little.
Here we go. No,
if we go to the slide that says HPV and then has like 150 related viruses on like a bullet point. We're going back.
Wait, this one?
Can we go? Maybe there's a bit of a lag.
So it says
it's
human,
the one.
850 related.
That one. Yeah, that puppy. Hell yeah. Heck yeah. Sorry, Jackie. Heck yeah.
Sorry, Jackie.
Sorry, Mom. So HPV is actually not just one virus, but a series of 150 or more. It is more. It's not or. It is more. There's more than them. Related viruses. So they're all part of the same big viral family. And it's spread by contact, these viruses. So skin contact, most often we think of sexually transmitted diseases. So HPV can be spread through sexual contact. And it's most well known for causing papillomas or warts. Again, it's a very common infection. Most sexually active people are infected with at least one strain of HPV at some point in their lives, and they have no signs or symptoms. But long-lasting infections with some strains of HPV can cause 6 types of cancer, most commonly cervical cancer. There are 4 strains that are most commonly associated with cervical cancer and other kinds of cancer. And again, out of 150, not all of them are going to cause cancer or put you at an increased risk. But we know that those that can put you at a significantly increased risk.
Right.
Okay, now we can go to the next slide because we can talk about how.
Okay.
This is when we come back to what we talked about earlier, right? How all cancer is genetic, meaning that all cancer is associated with genetic changes in the DNA of those cells that allow those cells to have like such a goofy instruction manual that they're able to behave like cancer cells and not like healthy cells. So HPV, this virus, has DNA. Viruses that have DNA sometimes can infect human beings. And then while the virus is in the body, if it's in there long enough, sometimes that DNA from the virus gets incorporated into your cell's DNA. So it's not just that the virus is still hanging out next to your DNA or next to your cells.
They fuse.
Exactly. They fuse. They integrate their DNA into yours. And sometimes that integration can cause other downstream genetic changes that then allow those cells to become cancerous. And that's why we say it causes cancer, because that viral integration is sort of the turning point for cancer. And you see there are 2 kinds of HPV, 16 and 18, that cause 70% of all cervical cancers. Wow. 95% of all cervical cancers are caused by HPV in general.
Wow.
But those 2 strains contribute to 70%.
Nightlife said that makes me glad I got my HPV vaccine this week. So yeah, shout out Fred Hutch for that. And then also Elle said, thanks to the HPV vaccine, I was the first woman in my family who doesn't have the HPV virus and never will. I have never had an abnormal cell unlike my mother and aunts. Thank you at Fred Hutch. So that's amazing.
That's amazing. I'm so glad to hear that.
That's amazing. And I think what's also really fascinating is that, like, you know, these viruses, there's DNA and RNA, and we talked about way back earlier is that viruses are incredibly intelligent, even though they have like no brain functionality. Yeah. But the way that a virus's entire goal is to replicate. Like that's what it's trying to do. And a good virus wants to replicate enough that it won't actually like murder the host. A bad virus will take you out fast. Like it wants to be in there for a long time. And that's why HPV lingers. And you said, and then eventually it will fuse. And then eventually it will
sometimes
develop.
Maybe.
It's so interesting. And then you talked about the dormant virus of the cytomeglia. I'm close. I feel like
CMV.
I'm close.
Yeah, you are.
I feel like I'm in the ballpark. So it's really interesting that we, you know, especially in the climate of the world right now, vaccines are amazing. And that is what's preventing this HPV from getting up in your stuff, in your hoo-ha, literally.
Yes, literally. Yes. Yes. We don't want them anywhere, but we definitely don't want them there.
Don't want them there. And by the way, Nair said, like, I'm rubbing off on you and I just corrupt everybody. And I'm like, I want to just impregnate everyone's brains with my little aliens over there.
Aliens is adorable. Are you kidding me? Wait, that's so cute.
No,
oh my gosh.
My God. Okay, so next slide.
Next slide.
Yes.
Okay. Oh my gosh. Okay. This is amazing. I just see a chat comment that's perfect. Someone said, I got the HPV vaccine, but I didn't get the double dose. Can you get too many HPV vaccines?
Oh, that's a good question.
Then someone else said, can it help after already getting HPV or would that be pointless? Jaded Fairy and Andy Q, both amazing names. Yes. I wish I was wearing my glasses so I could confirm I was reading those. But
no, you're
both
good.
Such good questions. Yes. So this slide is about Dr. Janice Galloway, who I mentioned earlier, who is just like the coolest. She's one of the scientists at Fred Hutch, and she leads work on HPV as well as a variety of other viruses. And she developed the vaccine by first understanding the way that we can form these things called virus-like particles. So if we think about, I'm trying to think of the best way. Okay, let's go back to the very beginning. Okay, so we talked about antibodies, right? Antibodies are immune cells that are trained to specially attack something specific, like a virus. In this case, HPV. And originally, Dr. Galloway was actually studying antibodies against HPV. And the reason why was because she wanted to know how we could detect these antibodies. Because if we can detect antibodies, we can detect who's been infected, the time between infection and cancer development, how much of the infection you need in order to see cancer develop. So she was just trying to study the antibodies as a tool for tracking who'd been infected to understand like how this cancer occurs, right? So she was studying antibodies. And then while she was studying antibodies, she discovered these things called virus-like particles, which when they were studying the HPV virus, these viruses have like a special little coat, like a little cage around them formed of these proteins. And so she was like, I wonder what would happen if like I put all of those proteins that form the cage around the virus, if I put them in like a little dish without any virus, like what would they do? And it turns out they self-assemble. They form themselves into a little structure that looks just like a virus, but has no virus inside, so it can't make anyone sick.
Whoa.
And they used these to create the vaccine. Because if we infect someone with a virus-like particle with these structures, they look just like the virus. Your body's like, that's HPV. I'm going to learn how to fight against that. But there's no one home. There's nothing inside to hurt you.
That it's like that's so cool. That's so cool. It's like it's almost like an invert Trojan horse. It's like it's like the shell, but there's actually no bad guys inside. It's like the inversion of a Trojan horse. That's so
if the Trojan horse was like just a sick ass sculpture. Like that's it.
And they're just like and then like the soldiers on the outside are still gonna attack the Trojan horse, but then when they crack it open, there's nothing inside. That's so cool.
Exactly.
That's so fascinating. Oh my God.
And like someone said in the chat, like, is it like, should people get like, so originally right now we say folks should try and get vaccinated. There's 3 doses. The reason why I forget, because I'm not the person who designed the vaccine, I think when I was chatting with one of our other scientists about why it's 3 doses, they were saying that it's just because you need that many doses to get like the strongest immune response. Because you have the first dose and your body's like, okay, we see this, we're gonna learn to fight it. But then maybe they forget a little bit. Right. And then the second dose, like, oh, right, we've seen this before. Like, okay, cool, we'll learn how to fight it. And then the third time they're like, we get it, we'll learn how to fight it. It's fine, I won't forget this time. It's like homework, you know, training.
Right.
And so that's when you do 3 doses. Typically they recommend that folks of all genders get diagnosed, so folks of all sexes get get vaccinated. And I think for women, they were saying that it should be between the ages of like 9 and 26. And I think for men or boys, they say it should be like between 9 and 21. They're generally trying to get you before you've been vaccinated or before you've been infected. And again, because it's most commonly spread through sexual contact, they're kind of going for like the pre-sex age.
What's very important, because some men are like, well, why do I have to do it? Aren't they carriers? And they can be completely asymptomatic and nothing, but it stays in there, and then you all know.
One, boys should be diagnosed, or people who are assigned male at birth should be not diagnosed. Keep saying diagnosed. Should be vaccinated.
Yes.
One, so that they, like you were saying, don't get infected and then pass the infection on to anyone that they're having contact with. Mm-hmm. But also because we know that now HPV, we've learned, doesn't just cause cervical cancer. It can cause other kinds of cancer too, like penile cancer, like rectal cancer, like head and neck cancer. Folks with any of those organ systems can get those cancers. So it's not only protect others, but it's also to protect themselves.
Right.
And originally it was these 3 doses, but we understand that that's actually a challenge sometimes to people getting these vaccines. Not everyone can get all 3 doses. So Dr. Galloway's team right now is studying, one, if it would be possible to have just 2 doses or even 1 dose and be just as effective. And 2, if getting vaccinated after you've already been infected with HPV would still be helpful, but it still give your body an immune boost.
Got it.
And so they're exploring both of those things.
That's really interesting. And also just to Nair's point, that's why new viruses might be way more deadly because they haven't mutated to be less deadly to their host and hence keep themselves alive. So that was Nair talking about earlier with the the viruses, and that they want to stay in the body, and that's a good virus. They don't want to take out their host too quickly. And I think that answers both Andy and Jaded Fairy's question about the HPV. So that was incredibly interesting and insightful. Oh my God, that was so cool. Oh my God. I feel like you blew my mind.
So cool.
That's so cool.
Right? Yeah.
So interesting.
I know.
So cool.
And then we have just one last slide, and then my slide with my email address in case people have questions. I'm more than happy to take those.
Oh, you're so wonderful.
But, oh my gosh, no, of course. But my last slide is just a bonus for you guys. So we already kind of talked about it, but it's because you're the poop coven, so I had to include some poop science.
I love you so much.
I love this study, and I was like, I just think fun for Haley and the guys and the gals out there. So this study, I love the title too. Fecal microbiota transplantation for the prevention of acute graft-versus-host disease in adults undergoing allogeneic, I never know how to pronounce it, hematopoietic stem cell transplantation, which I love how scientists are like, let me give this a full name.
They could have just said poop.
They could have just said like, we're going to take good poop and put it in people with a bad gut microbiome and see what happens.
That's so crazy. I can't. And can I also say that I feel like doctors we've talked about this, using the big words. And I understand that they have to, but it can create a sort of system where people, when they don't understand, feel like it's being gatekept, and it feels like it's being unacceptable. So I appreciate, it can feel elitist. Right. And so I appreciated that was something that we talked about in our initial meetings of like, how do we describe all this really complicated stuff in a way that like anybody could understand? Anybody listening when I post it on YouTube can like understand. So I think that's like really important. Yeah.
And I think it's important too, because like we need to have faith in people's intelligence, and intelligence and vocabulary are not the same thing.
Absolutely.
Everyone is like intelligent. Right. People are smart enough to understand the way that virus-like particles form, but they might not know the word virus-like particle because they haven't had the privilege, the time, the energy, the finances to have a higher education where they teach you buzzwords like virus-like particle.
Right.
People know the word poop, but they might not know the word fecal matter.
Right.
But that doesn't mean that they're not capable of understanding what's happening here, you know? And so like making it accessible and making it safe, you know, making it feel like this is something you can genuinely be a part of.
Absolutely. And
like, that is so huge, which is why I think it's so cool that like you and other like streamers out there make these safe spaces for people to ask questions and to like learn information. Like I think that's so cool.
It's so, I think it's really important. And also we had a donation from Nightlife Neko for $20 because all donations are doubled. So thank you so much, Nightlife.
Hell yeah, thank you.
I think Els, to point, science is for everybody. And like I say, you said earlier, you're once in the science club, always in the science club. And it's true. Sometimes I feel like because I'm not in the medical field anymore that like I'm not allowed to sort of weigh in on like new interesting things I read or like things I'm like, oh, that doesn't sound great. But the reality is like science should be for everybody, and everyone should get to understand what is going on in their bodies and what's going on in the world. So I think that's so, so important. I think this is all right. So now it's all up to the Poop Coven. Does anybody have any questions for Helen while she's still with us? And she can answer them right here. But she's so wonderful. I can't believe you put your email up too. I love you so much. It's so sweet of you. Any questions for Helen about anything that we discussed? Anything about Fred Hutch? Anything. And then I'm still, as is tradition, Helen, we end the podcast. I do a rapid fire date night where I just rapid fire ask you questions and then you answer them first thought, first thing that pops up. And then and then that's usually how we end. So I'll give them the room. Adorable. And then me and you are going to have our date night. And then we're going to this was amazing and super insightful. And I just want to say before the Poop Coven ask any questions if they have any, I am so grateful. This was incredibly insightful. You talked about things that were heavy and complicated in a way that wasn't heavy and it wasn't complicated. And I think when we are talking about something like the big boogeyman for me, which is cancer, or for others, that it could be. I have Chris Mack, who he runs a different charity. He's also one of like my best friends. He's one of the mods. He has health anxiety for heart attacks. Like we all have our thing that is that thing. So thank you for teaching us and talking about
Mine's
something.
autoimmune disease. Everyone's got something they're afraid of.
Everyone's got something. And I swear it's so interesting because it's when people have that thing, you either do things like this where you like talk about it and you learn and you like fight back and you say F you cancer and you go, you know, you like, or you can like be like, I don't want to know, ignorance is bliss. And they're both valid and they're both fine. But for me, I'm a fighter and I really appreciate that you told us all the different ways that people out there are fighting, scientists are fighting. And I will say it from the rooftops. Right now, what's going on in the world, like we have to have people like Helen and Jackie fighting, and we have to, and the poop coven.
And you.
Well, I just
literally all of you.
I just sit here, but like, you know, everybody has to keep fighting for education, for science. It's very important. So Jackie said making science accessible is so important to the stream for Fred Hutch program. I love that. I just don't know. I just don't have the vocab. Doesn't mean I can't ask the questions and solve a problem. Absolutely. The real question is Helen going to make a Twitch account so she can hang out with us in the future?
I don't use it much, but I'm down to learn more. I would hang out in the future. I love
to indoctrinate you into the poop coven fully. You need to get in here fully and be a poop for life because you're amazing and wonderful and we adore you.
I would love that.
And you literally like didn't bat an eye when I accidentally combined Fred and Helen at the very beginning, and I love you so
totally
much.
Works. I love it. I think it's a great nickname. I think it's fantastic.
Also Carly did a $25 donation, which is $50 donation.
Yeah, Carly.
All donations are doubled. Let's see.
Hell yeah.
Mine was cervical cancer, vicious flippy. So that HPV, FRELEN, yes. For Helen, how long have you been part of the Fred Hutch organization?
I joined Fred Hutch in September, October, November, December, January, February, March. 7 months.
It feels like I feel like you have the passion and the like knowledge of someone who was there for 7 years. I really do. I think it's amazing. And you're such an asset. And I really hope that they see
people are just so kind here.
Amazing. But you're also amazing. And Jackie's amazing. I hope you are
amazing.
Very appreciated. And so my mom had cervical cancer that spread to her heart and lungs. She was given a 2-month toe tag in 2016. She's still alive and driving me bananas. That's so wonderful to hear. And
I'm glad.
I think one of the beautiful things about Fred Hutch is that they're giving families time. You're giving people time. And we talk about in the Poop Coven all the time that time is one of the only commodities that it doesn't matter what anything about you is. We all want more of it. None of us feel like we ever have enough. So you providing people time with their loved ones is so important. So yes, please.
The last thing I was going to say was that, like, yes, I think time is huge. And I think also something that I've really come to appreciate about our clinicians is time and also dignity.
Yes.
Like dignity and autonomy, like the choice for how they want to move forward following their diagnosis.
Yes, absolutely.
You know, and I think that is like so huge because like we were talking about, healthcare can be a space where it feels like you have no autonomy. Sometimes it can feel like you're not in charge of your body and you're not in charge of what's happening to your body. And it can be really scary from every angle. And so I think when you have a clinician who's like, I know that it feels right now like your body is not on your side and like we're not on your side. So I want you to know that I'm on your side because like we, your healthcare team, like all we want is for you to be healthy and for you to live a life that is satisfying to you. And we're going to work within what that means to you. Because like everyone's definition is different. And like, that cultural sensitivity is like so
I love
important.
That. That's incredible. So I'm going to do my rapid fire date night with you.
Yes, I'm so excited. This is so fun. Oh my God.
So my first question,
so cool.
Stop it right now. You're so cool. So my first question, favorite color?
Yellow.
Oh, I should have guessed because I knew you're such a yellow. Like we have, I like read people's aura colors, and yours is so yellow. I would have said it. I should have guessed it. It's so yellow. Like you're just like Drifter. Drifter's also one of our other mods is like a hard yellow, and like it's just wonderful. Yellow people are always yellow, by the way. They're like always. Yeah, she's just like Drifter. Okay, it's such a good thing. It's such a good thing.
Okay, yay.
Lucky number.
7.
Okay.
Unoriginal.
Any
5
reason?
Also.
Oh, Addie! And she also loves 5. So any reason that you love 7?
So 7 I like because when I was a kid, Obviously there are some flaws now that I realize as an adult, but I was a kid. I loved Harry Potter, and there were 7 Harry Potter books.
That makes perfect sense then.
And 5, because that was my number in soccer. That was my jersey number. And there are 5 members of my nuclear family. My chosen family is much larger than 5, but I grew up with 5 people. So those are my numbers.
That's so many valid reasons for your lucky number. I love it, love it, love it. Favorite food, if you have one. That's a harder one.
Oh my God, I love food. I love cooking and eating.
Yes.
Favorite food, gut instinct, anything I can eat with crusty bread.
Oh,
like I love like a
yes.
soupy, stewy bean situation. Like,
and you
like I love
like
bread, crusty bread.
I just said the other night, I was like, you give me a hunk of bread and butter, I could survive off of it forever. Like literally.
Yes.
Oh my God.
I also
okay.
love dessert. Yeah.
What's your favorite dessert?
They're all so good. I love cake. I love making cake. Okay. I love eating cake.
Yes. It's
okay.
Favorite TV show.
Favorite TV show? Favorite TV show. Oh boy, oh boy, oh boy. You know, The Office is always a good comfort show for me.
I fall asleep to The Office every night. It's my comfort show. I literally sleep to The Office. I've seen it a billion times. Favorite Office character?
Okay. Oh, Dwight. Unapologetically Dwight.
I love you.
I love him.
Yes. My favorite character too. He's the best. He's the best.
Yeah, girlie. Yes, he's the best. We have to love him. Also, if I could be a character from The Office, I would be him. Job satisfaction.
I think I
ends
would
up with his soulmate.
Yes.
Child. Passionate. Driven.
Happy. He has so many hobbies.
He has Second Life too. He literally is just himself, but he can fly. I want that level of satisfaction.
I want that
in my life.
That is so good. I love it. I love it. Love it. Favorite movie?
There are also so many good movies. I would say I'll just go comfort because those are frequency things.
Yes.
I love so many movies. I love Strictly Ballroom, Princess Bride, About Time, Julie and Julia. Those are sort of the ones that. Also Hellboy.
Oh my God! And I love you sprinkle Hellboy in there. That's so funny.
Those are the 5 that instantly came to mind.
So cute. I love Julie and Julia. Okay, and
Julie and Julia is so good.
If you had to pick somewhere to travel to, where would you go?
Ooh, there's so many places I want to go. One of my best friends and I went to France for a few weeks a while back, and we went to we trained and backpacked whatever all over 7 different cities throughout the region. So that was gorgeous. My siblings and I went to Spain and Madrid this summer, which was beautiful.
Wow.
So I think next on my list, I want to go so many places, but I think next on my list are. Curious if you have any recommendations, but I think that Italy and Ireland and Japan are all pretty high on my list.
I'm going to England, Ireland, and Scotland next fall.
Stop.
I'm not even kidding. That's
gonna be so fun. Oh my God, that's gonna be so fun.
I'm so excited. We're going oh my God. Okay. I don't want to go into. I could talk about it for hours. If you
later, I'll hear about it.
Yeah, no, I'll tell you about it. If you had to listen to one song for the rest of your life, what would you listen to?
Ooh, one song for the rest of my life. How to listen to?
This is so hard. I'm sorry. I'm really putting you on the spot.
No, it's good. Because I'm thinking okay, I love Hozier. I think there's so many people I love.
Me too.
I might pick, though, this is going to be pretty unhinged.
No, it can't be.
I might pick an orchestral song from a Studio Ghibli movie.
Oh my God, guys, she has to be with us. She has to stay here with us. Right?
I don't know which one, but I'd probably pick something orchestral.
Oh my God. So you like Spirited Away?
Of course.
Okay.
Of course.
I love you so much.
Of course. I watched Ponyo for the first time this year in theaters with my friend, and I wanted to cry the whole time. It was so sweet and wholesome.
I just love you violently. And Nair said, if Helen doesn't come here to hang out from time to time, I will be disappointed. I feel like she'd fit in great. You are being indoctrinated to the poop coven. I'm letting you know that you're gonna probably Jackie, I'm so sorry. We're stealing Helen. Okay. And then last question. If you had a life mantra, something that you live by, or a quote or something that fills you up, feels inspiring, what would that be if you have one?
Trying to think. Okay, I have the one that I use at Fred Hutch a lot, my science motto. My life motto would probably just be I'll have to think of my life motto.
Okay.
It's probably dumb and earnest.
I feel like the head movement alone is your life motto. You're it's I feel like that is a life motto right there.
Be good, care about things, don't hurt other people. But I think that my science motto is science not shared, is science not learned. So if we're not disseminating our science, if we're not being equitable with the way that we are sharing that knowledge, we might as well not have learned it in the first place. What's the point? So science not shared, science not learned. That's my work motto.
Okay. I just want to say that we love you. Not just I love you, because I already knew that I loved you, but like I'm so glad the Poop Coven resoundingly also loves you. I knew they would. I told them all week last week. I was like, they are gonna love you. We love you. Thank you for your time. Thank you for your joy. Thank you for your passion for Fred Hutch. I am truly, truly honored for your time and Jackie's time. I think that Fred Hutch really is special. I'm so glad we kicked off 2025 with you guys, and I can't wait to see where this campaign ends up. And if we can all say thank you, so we might be chaotic, but we're cozy. Exactly. No way. Comfortable chaos. Thank you so much. And if everybody could please say thank you to Helen too. Thank you for your time, and thank you for just being awesome. And I absolutely adore you.
No, and thank you all so much. Thank you, Jackie. Thank you all. Thank you for having us. Thank you, Poop Coven.
Oh my God, yes, thank you, Poop Coven. Seriously, because none of this could be possible without you guys. So, thank you, Helen. I love your guts. And that was Helen from Fred Hutch, and I am Poop with Jex. And thank you for listening to our awesome podcast. Have a great night.
Bye. Thank you.